right, on to lesson 2. In lesson 1, we talked about how to multiply variable terms with exponents in it. And in lesson 2, we're going to talk about how to divide variable terms with exponents in them. If you don't remember what a variable term is, go ahead and go back to lesson 2 and watch that one. But you should be able to pick it up pretty quickly while watching this one as well. So at the end of this one, you should be able to explain and use the quotient of powers, power of quotient, and zero exponent laws. So what that means is, given one term with a variable raised to an exponent divided by another term with that same variable raised to an exponent, be able to know what to do with those things. And then if you have a fraction raised to a power, know how to distribute that exponent into that fraction, especially if there's a variable in it. So let's go on to that. All right. So say we have terms with fractions just to begin with. Okay. Any term with a fraction, like say our most basic term is like a constant. It was like 4. Okay. Well, this is actually a fraction, as you all know. It's 4 over 1. We just don't write the 1 because it's invisible. Okay. Now, say if I added, we know that the invisible exponent attached to this one is a 1 over the 4 and a 1 over the 1. And since this is the first term in a line of terms, or just the first term, we know that it has an invisible positive sign and an invisible positive sign in both of those as well. But this is really just written as 4. There's a lot of omitted information there, right? But if we add a variable to this, it becomes a little different. It becomes like, say, we'll use a good old x. We call this 4x, right? Now it's x, and you notice that x is in the numerator, right? Because this is actually x over 1. The 1 is just invisible, right? So this is 4x. We're actually attaching x over 1 in this. So we're actually multiplying two fractions together, 4 over 1 and x over 1. You just don't write it that way because to do so would be cumbersome and could be confusing for some. And of course, this is positive x as well, right? And in its most simple terms, x is x over 1 to the first. That's to the first, and this is positive, and actually this is positive, and this is positive. They're just invisible, right? But we just write it as x, right? That's way easier to write and quicker to write than all that information if you want to be technically accurate, right? So this is actually invisible too, right? There's a bunch of stuff going on because we remember from yesterday's or lesson 1 that anything raised to the first power is itself. So x raised to the first is itself. 1 raised to the first is itself. So we just don't write that stuff. It would be superfluous to do so. Extra and unnecessary. Superfluous. But anyway, so we write all this stuff. So I preface my my next example with this because, say for instance, I had something like 1/3 x squared, like that, right? This 1/3 is the coefficient of this, but this is saying, hey, this is saying there's a negative, or sorry, there's an invisible positive sign in front of this 1/3, okay, and that this is actually an invisible 1/3 over, or x squared over 1. So if you're going to combine this, right, which I encourage you to do so, especially when you're dealing with dividing terms with exponents, which makes it way easier to understand, you combine it so that the term is actually in the fraction, not outside the fraction like it is, right? You write it as such. So this is actually 1 times x squared, right? Because when you have fractions multiplied together, you multiply the numerators and then you multiply the denominators. So this would be equal to x squared, the one's invisible, right, divided by 3, because 3 times 1 is 3. So this would be written as x squared over 3. And that is what you get when you have a fraction like next to a fraction next to a variable term, right? So for instance, we have 5/9 x squared. This would be written as 5x squared over 9, right? These are equivalent expressions. Okay, so that's a real just quick way to combine them, so they put them in a way that's easier to do the math. Okay, most of the time, 95% of the time. The only time that this is easier is when you have like something like this. Something like that, right? But that you don't see that very often. Okay, and that's like higher level algebra and stuff. So we're not gonna worry about that for now. So for now, just do this. For now, just do that. Okay, for 7th grade stuff. All right, and finally, you're gonna see negative stuff and you're gonna see positive stuff. And sometimes the negative sign is attached to the coefficient in the numerator, and sometimes the negative sign is attached to the coefficient in the denominator, right? So it'll be something like this. You'll end up with something like a negative over a positive, right? This is my fraction bar. Or you'll have a positive over a negative, right? Either way, these equal a negative whatever the fraction is, right? You can just bring that negative sign out and just kind of leave it be, right? Continue to follow it down in your lines of algebra, right? But don't let it get you mixed up inside of your fraction, because if only one of the numerator or the denominator is negative, the whole thing is negative. And conversely, if both of them are positive or both of them are negative, right, because a negative divided by negative is positive, then the whole thing is going to be a positive, right? The whole thing will be a positive. The whole fraction will be a positive. So you can just kind of bring that fraction out, bring that positive out, or we just write positives as invisible. Right, we write them as invisible plus signs. Or if you write a positive, you're not wrong. You added extra stuff. Okay, so just remember that. If you see that one negative sign, you can just kind of bring it out in front, and then don't forget about it. Just kind of like disregard it when you're doing your math in here, because at the end you're going to tack it onto the front, unless there's more negative signs buried inside of there than you do at the very end, right? So we'll show some examples of that. Okay, so let's get to some things. All right, so when we're dividing terms with variables, or with variables and exponents, right? There's a numerator. Right? They may say, hey, give me a one term divided by another term, right? But remember, division bar, this is, even the sign itself is a fraction, right? It's this thing over this thing, right? So remember that this is a fraction. It's this thing over this thing, right? So set it up as a fraction, even if they give it to you in like a weird straight line, this term divided by this term. So let's say, for instance, let me pull up an example from the book. All right, so I don't like these. All right, so say I have like sure. Okay, say I have a 5x to the 5th, to the 6th, so don't get too confused, over like a 15, we'll do a negative 5x to the 5th over a next negative over a 15x to the 3rd. Okay, well, I can break this down a little bit. Okay, so first let's look at the first thing is I d the sign of the answer. Right? So we have a negative divided by a positive, so my answer is going to end up being negative. Okay, so I can kind of just set up my answer bar, get ready to fill in, put the negative sign in there in front of it so I don't forget it, and then I can go to work. 2, I'm going to determine or simplify, let's say simplify the coefficient. Simplify coefficient, right? Efficients, right? If you can, if possible, right? So these are the coefficients. So I had a 15, over a 5 over 15, and if you didn't pick that off right away, 5 over 15 is 1/3, right? So my fraction bar down here is going to be 1 over 3. Now you don't have to write the 1 if you're going to have a variable in the top, but I don't know if I have a variable in the top yet. All right, so now I'm going to break down this. I'm going to show you this first, what x to the 6th means, right? So x to the 6th is x. Let me draw a variable bar over here. Maybe kind of put this over here. So what I'm doing over here represents what's going on over here. So I have 1x times another x times another x. That's 3 times another x times another x. 1, 2, 3, 4, 5, and then we got one more x. Okay, there's 6 x's on top, all multiplied together. And you guys remembered yesterday, when you have a bunch of x's multiplied together, you add the exponents, right? 1, 2, these are all invisible ones, right? So x to the 6. Then we got 3 x's on the bottom. 1, 2, 3. Okay, so if I have 3 x's on the bottom and 6 x's on the top, well, these x's are going to cancel each other out until there are no more x's on the bottom. Okay, so there's 4 left on top. So 1, 2, 3, 4. So this is going to be x to the 4th. All right, so I can erase this 1, and my final answer is going to be negative x to the 4th over 3. Okay, another way to have looked at that, right, is to say, hey, I can say if my term here, my variable term on the bottom is my base, and this is the same base. They have to be the same base, because if this was like a y, right, there's no y's here to scratch out, right? So there's no y, I can't do that, right? So they have to be the same base. We'll say that this is m and this is n, right? Another way to write this is the base to the m minus the n. Okay, so that's another way you can look at doing that. Okay, or you can just be like, oh, okay, I have to go to war here. Okay, it's the denominator versus the numerator, right? And this one has 3 exponents versus this one's 6 exponents. Well, the 6 exponents is going to beat the 3 exponents, right? There's going to be no exponents left, right? And this is going to be, and when there's going to be 3 left here, right? I'm sorry. Did I miscount that? 3, 1, 2, 3. Oh, that should be. I caught a mistake. That should be 3. Oops, 3. Okay, that should be 3 because 6 minus 3 is 3. 6 minus 3 is 3, not 4. Anyway, sorry about that. All right, so there's going to be 3 left. All right, so that's another way you can do it. You can just go to, okay, this one's going to cancel. This 3 will cancel out 3 of those, so I'm going to have 3 left. So that's where. So what if, hypothetically, this will be 3, divide the variable exponents, and we'll subtract. Well, yeah, I'll say divide the variable exponents, subtract the top. That's gonna be, we'll just do top minus bottom. We'll just say put top minus, make it easy. Top minus bottom. Okay. All right. If base is same. Okay, all right, so there's that one. Okay, now what if for instance I have like what if m and n are the same? Like say I have a fraction and my base is, let's say y. I have my fraction of y, and this is y to the fifth. This is y to the fifth, and I'm like, oh, well, this is both equals 0 now. I have nothing on top. Well, these are all. I got a 1, 2, 3, 4, 5, and a 1, 2, 3, 4, and 5, and these all cancel out. Well, think to yourself, what were the coefficients of all of these, right? Well, there's a 1 in front of each one of these, a little dotted 1 in front of each one of these, right? And what is 1 times 1 times 1 times 1 times 1 times 1 times, it's all 1 over 1, right? So anything raised to the 0th is 1. Okay? And that is a law of exponents. It's the 0 exponent law. Okay? And finally, last thing before we summarize is we're going to distribution of exponents with variables. Okay, so say we have a fraction bar, and we have we'll say 5x y, and the x has a 3, and the y has a 2. Yeah, that works. And then we have we used 5 last time. Let's use a 4 and a 12. Yeah, I like that idea. All right, and then we do an x to the 6 and a y to the make this we'll do this next to the first. X to the first and a y to the negative. I haven't taught you negatives yet. We'll make this, yeah, sure. Y to the fourth. Yeah, that'll work. No, let's do y to the fifth. Okay, and we'll say that all this is raised to the 4th power. Okay. Well, the first thing we need to do is remember our PEMDAS. Parentheses. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Parentheses. It means we have to work inside the parentheses first. Okay, so first things first is we're going to reduce everything we can inside these parentheses. So this is going to be written as, well, 4/12. Remember, our first step is to reduce our coefficients. Well, first step is to see if it's going to be negative or positive. Well, this is going to be positive because a positive divided by a positive is a positive. So 4/12 is 1/3 again. Man, look at that, 1/3. Okay, and then let's look at our x's. We have an x to the 3rd and an x to the 1st. That x to the 3rd makes that an x squared. Okay, and then we have a y to the squared divided by a y to the 5th. The y to the 5th wins, makes that a y to the 3rd. That's a y to the 3rd. All right, let me bring this one in a little bit closer. And now this is all consolidated and easier. I'm going to go ahead and I'm going to write that as an invisible one. It's invisible, but it's still there. Okay, so now I have to apply this to both the numerator and the denominator. You can rewrite this as x squared to the 4th over 3y cubed to the 4th. Okay, that's rewritten as the same thing. Okay, so here now you're just using, it's like 2 different equations. It's 2 different expressions, one for the top and one for the bottom. Okay, so this one is going to be, well, I take the first, this is the invisible one. I remember from the last lesson, I have to raise the coefficient to the x to the power, which is 1 to the 4th is 1, and then I'm going to multiply the exponents of the variable. So 2 times 4 is 8x to the 8th. Okay, there, do the same thing. 3 to the 4th, so 3 raised to the 4th is 81. 81, and then y, 3 times 4 is 12. So there is my answer for that. Okay, so hopefully that makes a lot of sense to you. You're going to be given a little bit easier questions, kind of like 4 to the 5th times 4 to the 7th equals, or divided by, excuse me, let's say divided by 4 to the 3rd. That's going to be like, oh, well, that's just 4 squared, which equals 16. That's kind of be what like you're given, right? So this is algebra. This is the stuff you guys are going to be doing, right? So let's show you some examples of the power of the quotient stuff. Let's fill out this table here. All right, so say I have, okay, so power, quotient of powers. Let's see, what examples do they use in the book here? This is, all right, quotient of powers. Here we go. So say I have a 6.5. So this is the quotient of powers. Where did I write it? It's right here. This is the quotient of power law. I'm going to put this as a 1. This is the quotient of powers. Okay? That's the quotient of power law. And if I have this, and I'm like, okay, well, if I have this is an example of quotient of power laws, right? But I'll do another one here. Say I have like a 6.75 to the 7th over a 6.75 to the 3rd. This is going to be equal to 6.75 to the 7 minus 3, which is to the 4th. And I'll type that into the calculator and I get some number, right? But that's not a big deal. Okay, the quotient, the power of a quotient is, where did that one go? That is what we demonstrated over here, right here, right? So the quotient of power is saying, hey, if I have like a b and or an x, it doesn't really matter, okay? And it's we'll say an m to the n, right? And this is all to the z. Okay, it's whatever. It can be a hodgepodge of whatever. Okay, all right. It's going to be equal to b to the z, m to the z, over x to the z, n to the z. Okay, or m to the, excuse me, that's not quite right. We'll just do it like, we'll simplify it like that. It's like that. Okay, we'll just make it a little simpler like that. That is the quotient, the power of quotient rule. So if I have a fraction raised to an exponent, right, and that's that exponent raised, both the numerator and the denominator. So if I have like 5 over 10, and both of this is squared, this is going to be 5 squared over 10 squared, which is 25 over 100, right? Or 1/4. Okay, so there's that. Okay, and then the zero exponent law is say anything raised to the 0th equals 1. So like 6 raised to the 0th equals 1. Okay, so there we go. That is everything you need to know about lesson 2. Hopefully that helps you out.